In this video, we will be studying, basically answering some problems in calculus, uh, finding the answers. I'm not exactly sure what this topic is, but then, yeah, as you can see, the final answers are usually um, f of x is a relative either minima or maxima. So, yeah, we'll be solving two problems in this video. Uh, Basically, to determine if the x variable, what we're going to look for in given step 1 and step 2, we want to know if it is a relative maxima or minima. We know that it is, sorry, I'll just start writing them. Relative maxima, graphically speaking, it looks like something like this. This is the relative maxima. And when we say relative minima, graphically it would look like this. This is the minima. So given that, you also have to know that, let's just skip the formal definitions and just get over with how I remember it. For relative maxima, in the given sign chart, something that you will be making in step 3, this is called the sign chart. Basically, let's say this is the f of x, and we have our test points here, x equals something, x equals something. These test points are determined depending on what our x is in the first place, something that we'll be finding in step 2. So for example, x is equal to 2, then our 3 test points for that would be, okay, this is 0, 2, and 4. So 0, 2, and 4, yeah, we'll be tackling more on that later. But yeah, for relative maxima, you just have to know that in the sign chart, assume that you go from positive to negative. This is 0. And if it's relative minima, the sign chart will show negative to positive. So I hope you know. I hope you take note of that. And so, yeah. Let's, okay. Let's move with step 1. Step 1 is basically, you just have to find the derivative of whatever is given. So find the derivative. Find this one. I'm pretty sure in my previous videos, one of them at least, they talked about how to find the derivative given something like this. So yeah, that's exactly what we ought to do right now. So 12x. So this is the derivative already. And then for step 2, we have to equate, how am I supposed to call this? Let's just say derivative. We have to equate the derivative to 0. So basically it should look like this. And from that, we have to solve for x. Because whatever that x is, that's going to be a part, an integral part, or an important part in making our critical point. That is the critical point that I'm referring to. Let's say for maxima, it's this one, whatever that point is. For minima, the critical point would be this one. So going back, we just have to evaluate this simple algebra. And so we separate them into two parts. Negative 3x is equal to 0. x minus 4 is equal to 0. X is equal to 0, x is equal to positive 4. We have to, we'll be having two critical values. So we could find y, but yeah, we could do that later, or yeah, let's just do it now. But usually we already move on to step 3. If we are expected to graph what's given, then we look for the y. So yeah, let's look for y first. We use the expression that isn't the derivative, the normal expression. For some reason, we don't use a derivative to find the y given our two x values. It just seems so wrong. Anyways, so negative, then 0 raised to 3 plus 6 times 0 raised to 2 minus 9. The same with this one. Okay, 0, this is negative 9. And the other one is negative 4 raised to 3 plus 6 times 4 raised to 2 minus 9. Y is equal to 23. Okay, 0, negative 9, and 4, 23. I hope I get the numbers right. Let me just double check. Oops. That's for statistics. I might make a video on that, but I'm not sure if I'm confident enough to demonstrate the lesson based on a student's understanding of it, an average student. There it is. So this solution is basically what I'm doing right now, but this time I'm getting it correctly. I've tried this problem several times and I still managed to make the same mistake. So again, in step 3, we're going to make the sign chart. The sign chart is basically this kind of table. So given that we have x equal to 0 and x equal to 4, for 0, we surround it with numbers 2 points away from it, so negative 2, and then we write the number itself, x equal to 0, x equal to 2, x equal to 4, x equal to 6. So for the x equal to 0, it is surrounded by negative 2 and positive 2. For positive 4, it's surrounded by positive 2 and positive 6. So that's how we label the test points. My teacher said that you could manipulate. You could the looking for your test points. It isn't that strict, but I prefer that you do it this way. Something that's orderly. I just feel confident if I do it this way. If it's proper. So this time we want to sub x with using the expression, using the derivative, not this one. So negative 3x raised to 2 plus 12x given x equal to negative 2. So we get something like this. Negative 3 times negative 2 raised to 2 plus 12 times negative 2, negative 36. And we just basically get the operation of what that number is. So it's a negative. For x equal to 0, the same thing. What do we get? We get 0. And for positive 2, we get positive 12. So this one's positive. For if x is equal to 4, then it's 0. And if x is 6, we have negative 36. So that's basically negative. Okay, we've completed the sign chart. Now let's find the final answer. So x is equal to 0. As you can see here, from negative to positive, this is a relative minima. Again, from negative to positive, it's relative minima. For x is equal to 4, which is basically positive to negative, the other way around, x equal to 4 is a relative maxima. There it is. Okay. Usually the test would already accept this. The teacher would already accept this kind of solution, but if you're required to graph it, then we already have the maxima, the minima and the maxima. The test points, the critical points. So graph is as follows. We should assume that every box in this paper, this is equivalent to 2, this is equivalent to 2. So 0, negative 9, 2, 4, 6, 8, negative 9. For 423, this is going to be kind of long. Two, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 23. Okay, so this is the relative minima. As you can see, this is these three are associated, what I've encircled in blue. And these are associated with each other. It's the relative maxima. So let's graph them. It should look something like this. You could make a more accurate graph of it by using the scientific calculator to find the table of values of each. But that could, I don't think that's essentially necessary. So yeah, let's move on to the next example. For step 1, again, we find the derivative of what's given. So 4x then raised to 3 minus. We basically applied the theorems on differentiation. I believe I've made a video about it, and yeah, you can check it out, but I know that there are better resources out there on YouTube. Just check them out, whatever helps. So step 2, equate the derivative to 0. 4x raised to 3 minus 16x is now equal to 0. You evaluate it in order to find x. Apparently, I think we might have 3 critical points this time because we'll be having 3 x's, if I'm not mistaken. So next is 4x equal to 0. Then that x is equal to 0 and x raised to 2 is equal to positive 4. Square root x equal to plus minus 2, not 4. And then separate them from each other. One is negative 2, one is positive 2. So yeah, we have 3 critical points. We could proceed to step 3, but let's look for the y values of each x value. So using the original expression, let's evaluate, let's sub x in order to find what f of x is, that is y. So 0 raised to 4 minus 8 times 0 raised to 2 plus 6 That's basically 6. So 0, 6, that's one of the critical points. And yeah, let's just reuse this. This one's -2. This one's +2. So we just compute, look for the results, whatever that result could be, whatever that result is, you combine it with x to make the coordinate, that specific coordinate. I don't think it's a coincidence that the two x's have the same y value together with it. But yeah, shouldn't be that surprised. Okay, for step 3, we make the sign chart. F of x over here, and then the test points. So again, x is 0, -2, and +2. So -4, -2, 0. No, we can't go with 0 immediately. We need -1. Two, and then 4. There you go. Okay, so let's use the derivative to find whatever that value is if we sub it, the x with whatever the test point quantity is. So 4 times -4 raised to 3 minus 16 times -4. This is -192. This is 0. This is +12. This is 0. This is -12. This is 0. And this is +192. So I think we're ready to make conclusions. X is equal to -2 is a relative what? So from here, negative to positive, we know that this is for x equal to -2 since literally the test point, that's basically it, is in the middle. So negative to positive, that is minima. X equal to x equal to 0, x equal to 2 is so basically, okay, x equal to 0 is a relative maxima. And then x equal to 2 is a minima, the same as -2. Okay, now let's graph it. Should be easy, given that we already know the relative minima and maxima critical points. Zero, 6. Let's just assume that per box, this is just one each. So unlike a while ago. So 0, 6, 2, 3, 4, 5, 6, negative 2, 2, 4, 6, insufficient space. 2, 4, 6, 8, 10. And then positive 2, 10. Should look something like this. Okay, that's it for this video. I hope you've learned something from this, at least in a certain degree. So yeah, thanks for watching.